6-4, solve compound inequalities. Okay, so really all it is doing what you did yesterday, solving an inequality, except you have two inequalities written as one, like this. This is the and part of inequalities. Example 1 is 6 less than x plus 5 less than or equal to 11. So you got two inequalities in here. So I'm going to show you how two different ways to do this. Okay, you ready? Are we done? Okay. The first way. This is what I used to do when I was confused about these things. I would look at this and say, well, the first inequality is 6 less than x plus 5. The second inequality is x plus 5 less than or equal to 11. And then I would solve each one individually. Subtract 5. 1 is less than x, right? Which is the same as x greater than 1. I like to have my variables on the left side, so I just flipped everything. Is that okay? And then I solve this one, minus 5. So x is less than or equal to 6. Can everybody do that? Okay, and then you have to graph it. So x is greater than 1. So open dot at 1, shaded to the right. I'm not going to shade yet, I'm just putting an arrow until I'm done. And x is less than or equal to 6. A closed dot at 6, shaded to the left. Now, the only part that you really shade is if there's double shading. Meaning this is going to shade to the right past the 6, right? And this is going to shade to the left past the 1. But the only answers that make this true are where the shading part overlaps. So I'm only interested in this part right here. Now, if they split and go opposite directions, you have to show that they shade opposite directions. These are opposite directions, except the solution is where they cross. Yes?
So you'd want an open dot at 1 shaded
Right.
up right there, so that would answer look like.
Yeah, this is exactly what the answer would be. Even though it does keep going to the right, but these aren't solutions to the whole thing. Yeah. 7 does work. 7 plus 5 is 12, which is greater than 6. But 12 is not less than or equal to 11. So we're interested in solutions that are solutions to the whole thing, not just part of it. Got it? All right. The other way, which eventually, if you can get used to this, is just solve it the way it is. Now, I'm going to solve this equation, which we have rules for. If I add or subtract something to an equation, I must do it the same amount of times on the left side as I do the right side. Except there's 3 sides here, right? I have the left side, the right side, and the middle. So the rule stands, I have to do it everywhere. If I subtract 5 here, I must subtract 5 there and over here. Okay? So you can do it like this if you want, and that's how I used to do it. Or you can just understand what the rule says, and you get this. Now you still have to graph it the same way. You still have to understand what you're graphing. So if this is better to you, then do it this way. There's nothing that says you can't do it that way. Actually, I think maybe an example in your book might be like this. Okay? Example 2. I'm going to go ahead and solve these. This is an OR problem anyway. So given an OR problem, this is 2r plus 3 is less than 7, or negative r plus 9 is less than or equal to 2. This is easy because it's already split apart for you. Oh, he's not. He's got to be in one of those 2 classes. Yeah. Okay. So if you have 2 equations or inequalities set up already, just solve them and graph them. But there's something about these graphs that you should notice. So we'll go ahead and solve these individually. Everybody do that. Don't forget, when you multiply or divide by a negative, you have to change the sign. And then graph it. Okay, now my question to you is this. What do you notice about the OR problem and the AND problem as far as the graphs are concerned? What is your hypothesis? Yeah.
The OR problems, the 2 lines go opposite ways, and then the AND problems are meet in the middle.
Yeah, that's typically what's going to happen. Okay. All right, example 3. Did everybody get the right answer? Everybody remember to switch your sign here? Okay, got a closed dot there and an open dot here?
Yep.
Well, you guys are good. Example 3. You done early. 7 is greater than 2/3 times the quantity, 6q plus 18, quantity closed, greater than or equal to negative 9.
Well,
I would definitely split this apart. This is an AND problem. Everybody work it out. I'll do it as well. That's how I set it up. I split it apart. Everybody try to solve it. Once you distribute the 2/3, you'll notice on this problem the fraction goes away. And then just solve it. Forget to graph. Okay, so we got some weird numbers. Less than negative 5/4, which is negative 1 1/4. Open dot, just past the negative 1 to the left. Negative 5 1/4 is a closed dot just past the negative 5. This one's shaded to the right, this one's shaded to the left. It is an AND problem, so it's shaded between everything. So I know that was quick. Who actually got it done and got the right answer? Okay. The rest of you are still working. Any questions on this? There's nothing more to teach other than you have a compound inequality you gotta split apart every now and then, so, yes, Nate.
Sorry. I did it gently, but I ended up using it.
That's fine, it's good.
How
Cameron?
would you get the sign switched if you didn't divide by a negative?
Here,
Oh, you
I flipped the whole thing around. Okay,
I thought it was A.
it's Q.
Oh,
Looks like A.
Well, this is an A. You are from here, aren't you?
Well, it's kind of full.
Assignment.
Way back here. Oh, boy.
Let's get this done. You got 12 minutes. You ought to be able to get this done. Page 384. 4 to 22 evens. And the mixed review. All.